Now we would look at the same problem and try to solve for the current that is going through this 7 ohm resistor, but this time the modality would be using Thevenin's theorem. So let me click this. Okay, I'm good to go. Yeah, so this time the modality is the Thevenin's theorem. Okay, so in the Thevenin's theorem the first step is to identify uh, the element through which the current is required, or the element through which the element across which the voltage is required, and we identify it and we immediately open circuit it. So the first step is to identify the element and open circuit. I'd short circuit. I would type it in short, write it in shorthand as OC. My OC stands here for open circuit. Okay, so once uh, I open circuit, that is I open circuit this 7 ohm branch, I'll try and redraw the circuit. Okay, so this is how it would look like. So this is my 1 volt source. Okay, now this is my 1 ohm resistor, and this is my 3 ohm resistor. This is my 2 amps independent current source. This is my 3 ohm resistor, and this is my 2 ohm resistor. Sorry, this is 3 ohm and this is 2 ohm. And so first step is to identify the element through which I require the current, and I open circuit that element. Now let me change the current, let me change the color. Okay, so now these are the two terminals that I have open circuited. Okay, so now my next step is to find out VOC, that is across these two terminals. Okay, so let me name this terminal as A and let me name this node as B. So what would be VOC? VOC is nothing but, in this case it would be VA minus VB. Okay, and from the problem it is clear that VA is clearly at 1 volt, so VA is equal to 1 volt, and so my immediate goal is to find out VB. Once I find VB, I would have found out VAC if I subtract it from VA. Okay, now this is my circuit with which I have to work on now. Remember, we always remove the element. Once we identify the element through which the current is required, we remove it and then proceed with the redrawn circuit. So this is my basis now. Okay, so I'll go back to this. Okay, so now I have to find out this VB, the potential at this. Okay, again, so again I'll label this as C. I'll label this as a current I1. I would label this as current I2, and of course the current through this 3 ohm resistor is 2 amps. So if I write a KCL at node C, if I'm writing a KCL at C, what do I have? What are the entering currents? Of course the entering current is 2 amps, and also of course the entering current is current through this 1 ohm resistor, which happens to be VA minus VC by 1. Okay, of course VA is 1 volt, so 1 minus VC by 1. And what are the leaving currents? The leaving current is nothing but VC minus 0 by 2. So this is VC minus 0 by 2. So this is one equation and one unknown, and if I solve for it after few minutes of algebra, I am sure that you can find VC to be equal to 2 volts. Now my aim is to find out VB, which would help me finding VOC excuse me, which is VA minus VB. So I know the current through this 3 ohm resistor is 2 amps. So I know that this current is 2 amps, so that's nothing but VB minus VC divided by 3 is equal to 2 amps. So that's nothing but 2 amps is nothing but VB minus VC divided by 3. So if I rearrange this equation, I can easily find out VB which happens to be 8 volts. Very good. So what is my VOC now? The open circuit voltage, or sometimes the Thevenin's voltage. Okay, so it is nothing but VA minus VB. It's nothing but VA is 1 volt and VB is 8 volts. So 1 minus 8 would give me minus 7 volts. So my VOC is minus 7 volts. So my next aim is to find out RTH. Remember, while finding RTH, we have to redraw the circuit in which the element has been removed and kill the sources. Okay, so now we have to take this circuit and kill the sources, and looking through those two terminals A and B, I have to find out the equivalent resistance. So that becomes RTH. Okay, so let me redraw this circuit. So let me redraw the above circuit by killing the sources. Okay, so what do I mean by killing sources? Voltage sources are replaced. Okay, uh, voltage sources are replaced with short circuits, and ideal independent current sources are replaced with open circuit. So if I redraw this circuit, what do I have? I have something like this. Okay, so this is my 1 ohm resistor, and this is my 3 ohm resistor, and this current source is open circuited, so this branch is no more present. So this would be a 2 ohm resistor. Okay, so this is 3 ohm, this is 1 ohm, and this is 2 ohm. But remember, the voltage circuit, the 1 volt source is short circuited, so that is nothing but something like this. Okay, so this still is my B and this still is my A. Okay, I have to find the equivalent resistance looking through these two terminals A and B. Okay, now I'll redraw this circuit as something like this. Okay, so at B I have the 3 ohm resistor, and at this point I do have 2 ohm resistor, and at this point I have one terminal of the 1 ohm resistor, and the other terminal of 1 ohm resistor is connected to ground. So I can simply redraw 1 ohm as one terminal at this junction, which happens to be this, and the other terminal connected to ground via the short circuit. So this is nothing but 1 ohm. Okay, so these are my two terminals now, B and this is A. I have to find out the RTH looking through these two terminals A and B. Okay, so this is nothing but 3 ohms is now in series with these two, and 1 are in parallel, so this would give me 2 into 1 by 2 plus 1. This is 2 by 3 ohms, and this is 3 ohms. So this is B, this is the terminal A. So looking through these two, my RTH is now 3 plus 2 by 3, which happens to be 11 by 3 ohms. Now I do have both VTH and RTH. I'll redraw the circuit as VOC in series with RTH. So what is my VOC here is equal to minus 7 volts, and my RTH here is equal to 11 by 3 ohms. Okay, now these are the two terminals A and B from which the 7 ohms load resistor has initially been removed. Okay, these are the two terminals A and B from which the 7 ohm source is removed, and at A and B we have found the equivalent circuit for this entire circuit as a voltage source VOC in series with a resistance RTH. Okay, now I plug back the resistance 7 ohm resistor between these two terminals A and B. Now my objective is to find the current through the 7 ohm resistor. So this is very simple. The current I is nothing but minus 7 divided by the total resistance here happens to be 11 by 3 plus 7. So that would give me minus 21 by 11 plus 21 is 32. So that would give me minus 656.2 milliamperes. Remember, this current is again flowing from A to B. So if minus 656.2 is flowing from A to B, that means the answer is I is 656.2 milliamps, and the direction is, it is in fact flowing in the reverse direction, that is from B to A. So that finishes this problem.